Hello everyone, welcome back to our math channel online again. In this video, I will follow up with the previous video about the simplified trigonometric expression. But this one a little bit different, which is proving trigonometric identity. So we progress one step further. To prove the trigonometric identity, it means we have an equation, left side equal right side, and we have a balanced side, which is the equal sign here. Now our task is to prove the left side equal the right side, which is the fraction on the left equal the one sentence on the right hand side in this case. So to prove the trigonometric identity, you have two ways of doing it. First, you can just work on one side. Let's say you choose the left and you work on the left and you simplify it down until you get exactly the same like the right hand side. Then you can say, oh, now I work it out and it turned out the left side now equal the right hand side. Now, on the other hand, you can, if the right hand side more complicated than the left, you can use the right side and work it out only from the right hand side, and you work it down, 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 simplify it down until a simple expression look like the left side. Then you can say, oh, now I prove the right equal the left. So it doesn't matter, you can prove the left equal the right or the right equal the left. That's one way of doing it. The second way, let's say you work on the left side because it looks more complicated. So you choose the one more complicated, you simplify it down. And you simplify it until you think that it's already simplification, but still doesn't look like the right. Then you can proceed, say, I'm going to leave it here. Let's say I work from the left and I get the number 2, or I get something like A or B or C, right? Let's say you get an A. Then you will say, now I'm going to work on the right as well. And I work down until the right side also equal a B. If the left equal to B, now the right also equal to B, then B equal B. Then of course left equal right as well. So that's the second way of doing it. And keep in mind that there are some simple trigonometric identity you have to remember, so it helps you to work out better. So the first easy one is sine square x plus cos square x equal 1. And secant square x equal 1 plus tan square x. And cosecant square x equal 1 plus cos square x. So that is the three identity. Now in the future, you will learn the second one identity, which is we call a double angle identity. This will come later. So let's do this question now. So I look at here, I see this is the left side is very complicated. So I'm going to work on the left, right? So I will say this one will be on the top. I don't have anything to do with it, nothing to simplify. So I just copy it down. The bottom, I will change something. Sine x, which is sine x plus. Now tan x, I'm going to change it to become sine x on the top over cos x at the bottom. So now I notice that I might have to do a common denominator for the fraction down here. So the top, I still have 1 plus cos x. Now I'm going to mark this as left side, right? We work on the left. So now down here, I'm going to do common denominator. It means the first fraction here, the top have to time with this term, and the bottom also have to time with this, right? So the top will become sine x times cos x, adding with sine x. And when I multiply both top and bottom with the same expression, right? Then I can join them underneath one common denominator, which is cos x. So now I can copy the top, noting chain, still like this. The bottom, I see sine x and sine x here. I can take out the common factor. So I just chain like that. And inside will be cos x plus 1. And down here, I have a cos x, right? So now I see the top here is 1 plus cos x, down here cos x plus 1. They're the same, I can cancel it. And I have this 1 is 1 over sine x over cos x. Now it turned out 1 over sine x over cos x is the inverse fraction. It means I can twist it back, become, this is 1 over this, right? So this is the inverse fraction. So I'm going to twist it, become like this. And now when I twist this, become like this, I notice this expression is just equal cos x. So equal the right hand side. So I say, yes, it's proven, right? So this method, I work from the left, I lead to the right, no problem. I get it, from left become right. So I'm done with this one. Now let's find out what is the next question. Let's say the next question is a little bit more tricky. Let's say I have to prove 1 plus sine x over cos x plus cos x over 1 plus sine x equal 2 over cos x. So again, for this expression, it seems that the right-hand side is simple and the left is complicated. So I'm going to work on the left as well, right? For this second question, I'll work on the left because the left looks serious, right? Look complicated. So what I do is, so I have adding function on the left. So I'm going to say here left side, I work on the left. These are the adding function. So when we adding function, we treat them as the common denominator, just like we add in elementary fraction, right? So I will have, so this is left side. I will say, I'm going to do common denominator, right? So when I do common denominator, the top is 1 plus sine x. I have to time with this one down here, which is 1 plus sine x as well. Right? That's on the first fraction. Now down here, of course, will be the same. You have to time with 1 plus sine x. So that's the first fraction. Now, the second fraction, I have to time with this fraction, I have to time with cos x, right? So that the bottom is the same. So cos x times cos x is cos square x. And down here, of course, is still 1 plus sine x times with cos x. So now you see that they have the same common denominator. Now I can just make it simple. Now they are the same, so I'm going to join them, become 1 plus sine x square. That's the numerator, adding with cos square x. And underneath, one common denominator, which is cos x, times 1 plus sine x. Okay. Now I look at the right-hand side. I have to do something with number 2. I want to have something with number 2 because at the bottom, I also have a cos x. So I want to keep this one just like this. And up here, I have to do something to get number 2. So how do I get that? What I'm going to do is I'm going to expand this expression. So that will give me 1 square, adding with 2 sine x, 2 sine x plus sine square x plus cos square x. Right? When I expand this is scenario. This is a quadratic function, quadratic symbol, quadratic factor. So I make it become 1 square plus 2 times a times b, which is 2 sine x, plus b square, which is sine square x equals square x, over cos x over 1 plus sine x. Still not getting anywhere like this, right? So let's see how we're going to do. Now, I can combine this one with this one and make this become 1. Remember, one identity, very important, is sine square x plus cos square x equal 1. So I turn this become 1. 1 adding to 1 here become 2 plus 2 sine x. And down here, I have cos x times 1 plus sine x. Now, at this point, I achieve something with number 2. So I'm going to factor out the number 2 because I do have a number 2 in here in both. So I'm going to factor out number 2. Inside, I left with 1 plus with sine x over cos x times with 1 plus sine x. So at this point, that's so easy. I can cancel this, and I drew it become the right-hand side again, equal the right side. So it's proven. That's not bad. Okay. Now I'm going to show you maybe 1 or 2 more, right? Okay, so bear with me. Now this one is the top topic when I was in high school. It's hard to prove, but as I become a teacher, so I'll be able to prove it now. So maybe it happened to all of you, but maybe I'm not so intelligent. But anyway, let me give you another expression. And this one, I drew a top one. Okay, drew a top question here, number 3. So I'm going to prove what? I have trouble with this, still wet. Make it dry. So number 3 is prove what? Cos x minus cos x over cot x cos x. Interesting. Equal cot x cos x over cot x plus cos x. Let's see how we're going to do to this question. Now, it turned out this is the left side and this is the right side. This is the equal side. Now, they both look the same, right? The same complicated. So you can choose whether you work from the left to the right to the left, or the right to the left, or let's work each side until we come up with the same answer for both of them. So let's see how we're going to handle this. Okay. So I'm going to work on the left side first. Cos x minus cos x. So I'm going to change this one because it looks like this one I can change into something. So I'm going to change this become cos x over sin x and minus cos x. So that's the first on the top numerator. And the bottom, this will also become cos x over sin x, right? Cos equal cos over sin, and time with cos x. So the top one, I'm going to put one underneath and do common denominator again, which is this fraction had the time with sin x. But this one stay the same, right? Nothing change. So this will become cos x, you see nothing change, minus this I have to time with sin x, right? It means the top I have to time with the same thing. So this will become sin x cos x on the top. All of them will underneath the same equation, common denominator sin x over. Now this one, I'm going to join this, become cos x times cos x is cos square x. So top times top, and the bottom is just sin x, right? Now I look at this, I can cancel this with that. That's a shortcut, or you can use the first fraction time with the second upside down. You get the same thing. And just I like to have a shortcut like that, okay? So now what do I get? I get on the top, I get cos x. And it turned out that they have the same cos x. So I'm going to factor out the top. And inside I have 1 minus sin x. So I factor out the cos x and I times 1 minus sin x. That's for the top. The bottom, I have cos square x. So at this point, I can cancel this one, right? With the one down here, this is the power 2, this is power 1. So that's gone, and we still have a power 1 underneath. So this one is just 1 minus sin x over cos x. Now this look a little bit similar, but might be not. So I just leave it for now. I just pretend that maybe I stop here and see what the pattern come. Now it's hard to give the right, the left to the right or right to the left with the expression like that. To be honest, this is a tough question. So what I'm going to do, I'm going to work on the right as well to see if I can lead the right back to this expression. Then I can prove that they both equal this one, then they're okay, right? So let's leave it for now. I'm going to work on the right hand side. And I might have to erase here. Do it. So let me leave this for now, right? Leave this for now. I'm going to work on the right side now. The right side, I have cos x, cos x over cos x plus cos x. So I copy the right side. Now I'm going to work on simplify it, right? I'm working on it. So I'm going to change this become cos x over sin x. Cos x is cos over sin time with cos x. Down here, I'm going to change this become cos x over sin x as well, and plus cos x. So at this point, I'm going to have to do something with the common denominator for the bottom, right? The top, I just join this one with this one. So that will become cos square x all of this over sine x. So that for the top. Now for the bottom, I'm going to do common denominator. It means this fraction have the time with sine x. This one stay the same. So this will be cos x. Adding with this half the time with sine x and top half the time with sine x. So cos x sine x. And the bottom just the same common denominator, right? Join together. So at this point, I can cancel this with this one. And the top, I left with cos square x all of this over, I'm going to factor out the cos x here, right? Cos x. And 1 adding with sine x, right? That's how I factor it. So now, what this look like? I'm going to cancel this one. This is power 2, this is power 1, so this gone. And this will become cos x on the top. At the bottom, I have 1 plus sine x. So now I simplify well enough, but I'm going to look at the left here and I look at the right here. Are they look the same? No. So I haven't drew it yet because I work it out, I work everything down, and the left still look different from the right. So what I can do about that? I don't know. Let me think about it. So what I'm doing, I'm going to just leave it the right as this one, right? Let's leave it for now. I'm going to continue. Instead of I stop here, I'm going to continue to do something about this to lead this up to there. So I'm going to copy the left again. Left side is 1 minus sine x over cos x. Now I'm going to have to turn this into this. And I look at the 1 plus sine x, the 1 minus sine x. So I come up with the idea that as long as I see this pattern, it looks like I can manipulate something. It means I'm going to tie it with the same like this. So I'm going to change something, right? 1 plus sine x. And of course, if I tie the top with this one, then the bottom I have to do the same, which is time with 1 plus sine x. So now, the top, I have 2 brackets. And when it looks like 2 brackets, I can turn it into this is a minus b times with a plus b. That's look like the pattern like that. And that is a quadratic function. The completing is a perfect square. So this will lead into a square minus b square. And our a is 1. Our b is sine square. So 1 minus sine square x over cos x times with 1 plus sine x. So when I multiply with this, I get this. And it turned out, if I remember the trig identity, remember the first trig identity, very important to use sine square x and cos square x equal 1. It means, let me write down, sine square x plus cos square x equal 1. So it means if I transfer this over, it means 1 minus sine square x equal cos square x. So this one, I can change it into cos square x because this equals this, right? Based on the first trig identity. And down here, I have cos x times 1 plus sine x. Now, at this point, I can cancel this. That's become power 1 and this gone. So I left with cos x over 1 plus sine I. And this exactly this one equal the right hand side. This is the same. So now after the first time I worked, I didn't get the goal achievement. Now I work again. One more step further, I turn into the same for both of them. So this is proven again. So I show you how to do it. And there are the way of recognize the pattern, but again, I think this stuff you have to pick up the pencil and work on your own until you achieve it. But you will see, it's not too bad. I show you a little bit of this. Now, because we have to continue to prove another, which is a double angle identity, and I guess that will be the end of our chapter. So I'm going to stop the video here, and I'm going to stop the video here, and I hope you enjoyed this video, and I will see you. Stay tuned for our next video for the double angle to see if I can have time to do that. So thank you for watching, everyone. I hope you enjoy it. I like proving tricks. Once you be able to prove them, you will feel fun, right? Feel a sense of achievement. So anyway, bye for now.